Students, we have seen in the last video the analysis of series RLC circuit. Now we will solve some numericals on RLC series circuits. Once again, here we are using the formulas. The standard formulas are the relation between voltage and current and impedance, that is voltage V is equal to I into Z volts. Or in other words, if you want to calculate Z, Z is equal to is the ratio of voltage by current, so many ohms. Or if you want to calculate the current, that is I is equal to V by Z amperes. Also we know what is the impedance. The impedance Z is given by, that is under square root R square plus X square. I will write here X square because we have to find out here it is effective reactance. Effective reactance. What do you mean by the effective reactance in the case of RLC circuit? Suppose if you have got a resistance of R having the inductance of L Henry and capacitance of C farad, they are all connected in series and it is excited by a source of AC voltage V volts with a frequency of F hertz. Then we have to calculate the steps involved are calculate first. You have to find out what is a XL. The XL is equal to 2 pi F into L, so many ohm. The next step is you have to calculate what is the value of XC, that is equal to 1 by 2 pi FC, so many ohms. Then you have to find out the effective reactance X. The effective reactance X is, it is a difference between the inductive reactance to capacitive reactance. Once again you have to take, for example, if it is XL is greater, then it is XL minus XC. If XL is greater than XC, or X is equal to XC minus XL in case of XC is greater than XL. That is, in the case of XL is greater than XC, the resulting angle, the phi, what we are getting is, it is lagging in the nature. It is a lagging in the nature. In the case of, if the XC is greater than XL, then phi is lead. Phi is the lead. The basic equation remains same. What you have to do? Find out XL, find out XC, find out the X. Either it is XL minus XC or it is XC minus XL. Once again you have to go for what is the value of impedance. And the rest of the formulas are remains same. That is, your cos phi is, once again, it is R by Z, or R is equal to Z cos phi and X is equal to Z sin phi. Here the X is effective reactance. It is called as the effective reactance. Either it is XL minus XC or it is XA minus XL. Then how to find out the value of phi? Phi is equal to, once again it is tan inverse of X by R. Once again X is the effective reactance. Then the power you have to calculate, P is equal to, once again it is V into I into cos phi, so many watts, or it is P is equal to I square into R so many bits. This formula, whatever we are derived here, it is similar to the RL series circuit and RC series circuit. Only the difference between RL, RC and RLC is that the finding out the effective the reactance. With this preamble, we'll start solving some of the numericals. Now I have got the numerical number 1. The statement of the problem is, just if it is not clear, just you have to note down. A 230 volt 50 hertz AC supply is applied to a coil of 0.06 Henry inductance and 2.5 ohm resistance connected in series with 6.8 microfarad capacitor. Calculate 1 impedance, 2 current, 3 power factor, then 4 is the power consumed. For the given statement, the first step is to draw the circuit diagram as per the statement of the problem. That is, here the resistance, inductance and the capacitance are connected in series. What is given is given a coil having inductance of 0.06 Henry and inductance resistance is 2.5. Means it is a combination of 2.5 ohm resistance R and with the inductance of L Henry, that is connected in series with a capacitance of C is equal to 6.8 microfarad. We have to draw the circuit accordingly. That is, I will draw a resistance of a coil having 2.5 ohm, the inductance of 0.06 Henries and the capacitance of 6.8 microfarad. These three elements or coil and a capacitance are connected across a source of voltage 230 volts and the supply frequency is 50 hertz. So what is the first step? He asks you to find out the impedance. The impedance formula, Z is equal to, it is R square plus X square under square root. The value of R is given, that is R is 2.5 ohm. Then the next step is to find out X. X is, it is nothing but it is XC minus XL or XL minus XC, whichever is greater. Then our ultimate goal is to find out first XL and XC. That is, first I will calculate what is the value of XL. XL is equal to 2 pi FL. Then you substitute the values. 2 pi, F is 50, L is 0.06. Therefore, the value of inductive reactance, what we are getting is 18.85 ohm. Similarly, you calculate what is the value of XC. That is equal to 1 by 2 pi F into C. That is equal to 1 divided by 2 pi into 50. C is 6.8 into 10 raised to minus 6. 10 raised to minus 6. The value of XC, what we are getting here is 468 ohm. 460 ohm. See here, you have to compare the reactance. It is 468, it is 18.85. Therefore, your X will be, it is XC minus XL because XC is greater than XL. Therefore, the effective reactance is, it is a difference between these two. That is 468 minus 18.85. That I will keep as it is. So many ohm X. Okay, or you can simplify by deducting 18.85 in 468. The ultimately what I want is the value of Z. Z is equal to, now under square root, what is the value of R? It is 2.5 whole square plus, what is the value of X? X is 468 minus 18.85. Whatever value you are getting, that you have to put directly, or you can write as it is 468 minus 18.85 whole square. Therefore, the value of Z, what you are getting is 449.2 ohm. That is the value of impedance. The next, what he asked is the current. What is the equation for the current? The equation for the current is I is equal to V by Z, where V is equal to, it is given value, that is 230 volts, and we have calculated already in the first step. Z is equal to 449.2 ohm. Just have to substitute these values, and thus what you are getting here is 230 divided by 449.2. That will comes out to be, the current will be 0.512 amperes. That is the current I. Then the third, what is asked is power factor. We have got a standard formula for cos phi. The cos phi is given by, that is R by Z. We know all the values here. Just have to substitute the value of R. The R value is 2.5 ohm. The Z value were calculated already. That is 449.2. That is what we are getting here is 89.7 degree. Then whether this angle is lag or lead, can see here XC is greater than XL. XC is greater than XL. Therefore, if XC is greater, then the angle is leading. Okay, that is why you have to write 89.7 degree lead. In the third case, what is asked is the power conjugate. Now we are finding out the power conjugate. There are two equations. You can make use of any one of the equation. P is equal to, one straightforward, the formula what we are using is VI cos phi. We already calculated these values. That is, V is 230 volts. Current I is 0.512, and the power factor is, it is cos of 89.7 degree. Here power factor what we are getting is the angle 89.7. we are getting the value of cos phi and calculate cos of 89.7. You work out that, you can find out, can put it here. Then if you are putting VI cos of 89.7, the value of the P, what we are getting is the power consumed as 0.656 watts. The value of the power factor, that is using the calculator, that is what you are getting is 0.0057. That is the value of the power factor what you are getting. Okay, this is how you have to calculate. Very simple. Write whatever you ask. If it is asked impedance, write the impedance formula. R is given value. Find out the X. It is a difference between the two reactances XL and XC. Then you have to substitute in the formula and you are getting the impedance. So similarly, for calculating the current, we have got a simple equation. I is equal to V by Z. V is given. Z you are already calculated in the first step. Then you can put the values of V and Z. Then what we are getting is the current. The power factor we are calculating, it is a cos phi is equal to R by Z, or you can find out phi first, tan inverse of X by R. Then that is the angle what we are getting is 89.7 degree lead, because XC is greater than XL. Then you find out cos phi is R by Z, that is 2.5 divided by 449.2, it will come out to be 0.057. And P is equal to VI cos phi. Substitute the value of the VI and cos of 89.7, where the power consumed in the circuit is 0.656 watts. Or you can try the P is equal to this formula also. P is equal to I square into R. Once again we are getting the same value of 0.656 watt. Okay. Now we will move to the numerical number 2. Just I will read out for the clarification. A coil of power factor 0.8 connected in series with a 110 microfarad capacitor. The supply frequency is 50 Hz. The potential difference across the coil is found to be equal to the potential difference across the capacitor. You read the statement very carefully. The potential difference across the coil is found to be equal to the potential difference across the capacitor. Calculate the inductance and resistance of the coil. Here the coil means it is a combination of resistance and inductance. This coil is connected in series with a capacitor, and it is excited by a source of AC voltage. Now we will first draw the circuit. The coil means it is a combination of a resistance and an inductance. Then it is connected in series with a capacitor. Here what is given is it is excited by a source of voltage V with frequency 50 Hz. Is not given the what is the value of the V. Then is given a statement that is very important. The PD across the coil found to be equal to the PD across the capacitor. Is given one condition. Make use of this condition and you have to solve the numerical. We will see that. That is, the voltage across the coil I will call as V into V coil. I will represent this as a V coil, and the voltage across capacitor I will write V cap for more clarification. elements, that is the resistance R of the coil, L of the coil and capacitor C are connected in series, then the resulting current in all the element is I. Here you can split this numerical into two parts. That is the voltage across the coil. It is nothing but it is a combination of RL circuit, and you have to compare with the combination of only the capacitor. Okay. First we will look into the what is the voltage across the coil. How we are finding out V coil? It is, once again, it is a product of I, the current flowing through the resistance and the inductance is R, and the impedance of this RL circuit I will call as ZL. The impedance of this circuit I am calling as a ZL. That is I into ZL, where ZL is equal to under square root R square plus XL square, where XL is equal to 2 pi FL. Okay. Now, the voltage across the capacitor I will write as a V cap is equal to what? It is product of I into XC. You consider, that is, if you have got a capacitor circuit, only capacitor circuit, if the current is flowing here and it has got a capacitive reactance XC, then what is the voltage? Voltage is, it is a product of I into XC. Therefore, V cap is nothing but it is a product of I into XC. Now, what is the condition is given? The PD across the coil is equal to PD across the capacitor. Therefore, I will make use of that. V coil is equal to V cap. Therefore, IZL is equal to IXC. I am making use of this same identity. Just I am putting, instead of V coil, I put IZL, and IXC I will put IXC. Therefore, on either side I get cancelled. Therefore, the ZL value what we are getting is equal to XC. Then what is XC? The capacitor is given. The value of the capacitance C is equal to 110 microfarad, and frequency is also given, that is 50 Hertz. Then find out what is the XC. XC is equal to 1 by 2 pi FC. You substitute the values there. This 2 pi into 50. C is 110 into 10 raised to minus 6. That is what we are getting is the 29 ohm. Okay. Means the impedance of the circuit ZL, that is what we are getting here, is XC. What is the value of XC? XC is 25 ohm. Means, in other words, the impedance of RL circuit is 29 ohm. And for this coil is given a power factor is 0.8. How we are finding out the power factor of a coil? Once again, same formula, cos phi is equal to R by ZL, or in this case it is can call ZL. Therefore, it is possible for us to calculate what is the value of R. That is, R is equal to ZL cos phi. Therefore, the value of the R what we are getting here is 23.2 ohm. Okay. Then you can find out what is the value of XL. XL is equal to under square root ZL square minus R square. Same formula. ZL square minus R square. ZL is known 29 ohm and it is 23.2 ohm. Therefore, the XL what we are getting here is 17.4 ohm. Or you can find out from the cos phi is equal to 0.8. Find out what is the phi, that is phi is equal to cos inverse of 0.8. Or you can make use of another formula, that is XL is equal to Z sin phi. First find out phi, that is equal to cos inverse of 0.8. From that also you are getting the value of what is XL. Here it is straightforward, it is ZL square minus R square, it is yielding the same result. Once if you know XL, we know the formula XL is equal to 2 pi FL. Therefore, L is equal to XL divided by 2 pi FL. Substitute all the values here. The what we are getting here is L is equal to the value of XL is 17.4 ohm divided by 2 pi into F is 50 and XL 2 pi F, sorry, it is correct, 2 pi F, that's all. Therefore, the value of inductance what we are getting is 0.055 Henries. We are getting 0.0. It is very simple. You have to apply the basic equation of the voltage, current and impedance equation. And when if it comes to the statement, just you have to read the carefully the statement. Accordingly, you have to write the equation so that you are getting the solution. Then we'll move to the third numerical. Once again, I will read out the numerical for your benefit. 3 impedances connected in series across 220 volts, 50 Hz supply. The first impedance is 10 ohm resistor. The second is coil of 15 ohm inductive reactance and 5 ohm resistor. And third consists of 15 ohm resistor in series with 25 ohm capacitor reactance. You read the problem carefully and accordingly you have to draw the circuit diagram. And he asks you calculate the current, phase angle and power factor and the power consumed in the circuit. There are 3 coils having combination of either resistance and inductance or resistance and the capacitance. You will draw the circuit by reading the statement carefully. 3 impedances connected in series, okay, across 220 volts, 50 Hz supply. The first impedance is 10 ohm resistor. First impedance, it is only the resistance having the value 10 ohm. Therefore, I will draw a resistance having 10 ohm. The next, the second impedance is a coil. Coil means what? It is a combination of, once again, the resistance and reactance. Is given resistance of the coil is 5 ohm and inductive reactance is 15 ohm. Okay. Therefore, what I am doing here is I will draw the resistance of the coil first, that is having 5 ohm and inductive reactance of 15 ohm. Then the third one is consists of 15 ohm resistor in series with 25 ohm capacitor. The third, it is a combination of a resistance and capacitive reactance. The resistance value is 15 ohm and capacitive reactance value is 25 ohm. That is 25 ohm. It is 25 ohm. Is given this as XC. This is your XL. Okay. This circuit is connected across a source of 220 volts, 50 hertz. Okay. Now, the numerical is very simple. Here you have to reduce the circuit. You have to find out effective resistance, adding all resistance value. What are the resistance value you have got? It is 10 ohm, 5 ohm and 15 ohm. Therefore, R effective is 10 plus 5 plus 15. That is 15 plus 5 20, 20 plus 10 it is 30 ohm. Then you have to find out effective reactance. What is the effective reactance? The effective reactance is the difference between the reactance of capacitance and reactance of inductance, whichever is greater. Here the XC value is greater than XL value. The XC has got 25, XL has got 50. Therefore X is equal to XC minus XL, that is equal to 25 minus 15. Therefore it is 10 ohm. That is, it is R effective. R effective. Then it is 10 ohm is XC is greater, then it is act as capacitive circuit. Overall it is act as a capacitive circuit. If you want, you can redraw the circuit for that with R effective of 30 ohm and effective reactance of capacitive reactance of XC is equal to, now X effective is equal to 10 ohm. Then the same voltage is applied here, 220 volts and 50 hertz. Then calculating the current is very simple. That is, the first thing what you have to calculate is I. That is, I is equal to V by Z. Here we have to find out Z.